Hello friends, today's question is route to leaf paths. Its difficulty is medium. Given in the question, given the binary tree, you need to find all the possible paths from the root node to all the leaf nodes of the binary tree. The node is given, the path should be written such that paths from the left subtree of any node are listed first, followed by the paths from the right subtree. Let's understand the problem first. So this is the given tree to us. We have to return the paths like the path between the root. This is the root and this is the leaf. We have to return this path 10 20 40 10 20 60 and 10 30. Means we have to return just like this 10 20 40 10 20 60 and 10 30. We have to return path like this, and this is given that the paths which are paths which on the right side should be listed first, which will be covered in our code. Means path should be right on 10 20 40 first, then 10 20 60 after that, in the last 10 30. What's given? This is the same example as we can see 1 2 4 1 2 5 and 1 3. Here 1 2 and 1 3. Here 1 20 40 1 20 60 and 10 30. Sorry, 10 20 40 20 20 60 and 10 30. Then expected complexity is big of n and space is big of h. We will code according to that. Then the topic tags are tree, data structure and recursion. Okay, binary search tree. As the data given in binary search tree, so it is a binary search tree. So what can our thought process? So we need what we need to traverse the tree. We need BFS or we need DFS, but as you can see, we don't need BFS here because BFS travels level wise. Means it goes like 1 2 3 and 4 5. We have to go like 1 2 4 1 2 5 1 3. So we can't use BFS here. So what will we use? DFS. DFS has the three types. We can see three types, but yes, it has three types. It defines when the node will get printed. Pre means first node, then first will print the node, then left and right in order. We will first print the left, then node, the root, then right. In post we will print first left, right and then node. So what we'll use here? DFS. We will use the DFS to traverse the tree. How the DFS traverse? DFS goes until the depth, until the null is found. So how can DFS works? So this code is written, it is a pre-order of DFS because we are printing the node first. Node means we are printing the root first, then we are exploring the left, exploring the right. So we will see how this traverser works on this tree. So now see, this DFS will be called for the node 1. So node 1, so print will executed. So after print execution, it will be like print 1. So we print 1, then goes to DFS node left. So we go to 2. We are going to. Now this is recursive function, so it will go to again calling. It will again call. So printing node 2. So we are 2. Now it is again calling the left. See, it is again calling the left here. So it will go to 4. Now we are going to 4. Yes, 4. Then after coming to 4, it is again calling to left, but here the left is null. So the call will back to the call of 2. Means from here we will go to, it will call the left because it is null, so not executed. Then it will call the right. It is also null, so it will also not executed. So call will go to the 2. Now until the last call we were here left, we called the left. Now we will call the right. Now after calling the right we come here, so we'll write this 5 in the list. Now here also the 5 has the left and right as null, so call will go back to the 2, call will go back to the 2, but all the commands, all the lines are done in the call of 2. Now the call will go to the function of 1. We are here in the function of 1, so it will call the right, it will call the right of 1, right of 1, we'll call the right of 1. Now right of 1 is 3, so it will go to right of 3, so we'll read the 3. And now as the 3 has the both null, so this will be called, but call won't be made because both are the null, and then call will go back to the 1, and then execution will stop. So finally this will be the final outcome of the DFS traversal. Now you can see we have gone to the depth, means first 1 1 2 2 4 4, means we have gone until the depth, so we wanted this. But here the little modification that we wanted, because here you can see 1 to 4 it is the path, but 4 5 this is not the path, so we have to store path like 1 to 4 1 to 5 1 3. So will the make modification like this, means what we want, when we go like 1 2 3, we'll store this as a path, but 1 to 4 we will store this as a path. But when we go to 2, when we go to 2, after calling, after function ends we go to 2, we will erase this 4 from our path and add this 5, means what will we do, 1 2 and 5. After 5 call is ended, when we go to 2, we will also remove the 5 as well as 2 from the list, means we will remove the 5 and 2 from the list and we'll keep only 1 and add new 3. So what will be the condition? The condition will be that when the both childrens of the some node are null, then means we have reached to the leaf, means both children are null, then we have reached to the null, then we will add the path to our paths vector. Okay, we will add to our paths vector. Let's see the code, how the code looks like. Now this is the code, this is the main code which calls the helper function. This is the helper function which is DFS, means depth first search in pre-order. Okay, so we are, this is the first condition, if the node is null, then we are returning. Now as I said earlier, we have taken one path which will create the path, and this is the 2D vector answer which will store all the paths, means 1 to 4 1 to 5, which will contains all the paths, vector of vectors. So this will contain the current path and this will contain all paths. Now we are pushing the, as I said in the DFS, we are here printing the node. We are printing, instead of printing, we will store here in the path variable, in the path vector here. And see, as I said earlier, if both children are null, if both nodes left and nodes right are null, then we have reached to the leaf, means this is the last node, root to leaf. So we will add the entire path that we made during the iteration or recursion. We will add to the answer, means this answer we will add to this. Okay, and otherwise if both children are not null, then what will we do? We will just continue our pre-order recursion. And this is the very important line that I said you earlier, that we have to remove the last element, that when we complete our iteration and we have to explore another path, then this is the most important line. This shows that we are removing the element, we are removing the last element that we put inside the vector in the path. Okay, now I will show you how I will show you the traversal of this. Okay, how the code works for it. How the code works. Okay. Okay. So taking this for the also taking the code for the reference, so we can see side by side code and the tree. Okay. Now you can see first the function is called with the root. Here the root is here the root is 1, so function is called with the root. Then if we are checking nodes left or right is null, no, so this condition will be called left. So path, in the path it will be stored in the path, so 1 is added to path, then 1 is added to path, then the function will be called for the left, this, so after 2, then function again will be called for the 4 left, then 4. That's right. Now after reaching the 4, we found out that both are the null, both are the null, both are the null, both are the null. So we will add, this in our main answer variable. So let's make it as answer variable. Now what will we do is we will now we will go to 2, because here iteration is ended. We will go to 2. Now we will call for the right. So we will come here, but before doing that, when we on the 4, we check both left and right, both were null. This condition gets true, so we pop back the 4, from the array, because we have found out the path from 1 to 4, so we pop out the 4. So what it becomes 1 and 2, 1 and 2, 1 and 2. And now we called for the 5, for the 5, it will get added, here. Also here both children are null, so this condition gets true. It is also pop back, so how it becomes 1 and 2. Now the call is done here, call goes to here, call also done here, because both the calls are done, left also done, right also done. Now call goes to here also the 2 will be erased by this line, call 2 will be erased by this line, Now we are here on the recursion of 1, here left is already called, we will call now right. On the right there is 3, we will add 3, and as we on the 3 is both children are null, so this condition gets true. If this condition is get true, then all the paths are added to the answer. This path gets added to the answer. Okay, and after that path dot pop back means we are popping the 3 back, and continuing the iteration or the recursion of 1, but the recursion of 1 is also ended. We have called the right, and we also pop path dot pop back 1, so also path pop back 1. So and here our vector is ready, which consists all the paths 1 to 4, 1 to 5, and 1 3. So we will return this vector, this vector. Now understand the code. It has, as you can see, it has the time complexity of big of n and time complexity of big of h, because we are storing the nodes for storing the paths. So this is the time complexity. Now let's see the code and run the code. This is the code. It is the helper function. It's the helper function. After that, this is the main condition, which checks the leaf. Okay, and this removes from the path. Okay, this was our helper function. We are calling it with the root here, calling it with root. Okay, now let's run the function. Let's run the code. Yes, now submit the code. Yes, all test cases are passed successfully. Both the C++ and Java code given in the description. Thanks for watching.